Hey, all you cool cats and kittens. That is going to be my sign on now that I've watched Tiger King, and probably the only good thing that I got from watching that show. I mean, good is a relative term, but I think it's pretty fun. So, what we are doing today is, well, today and tomorrow, we are going to be looking into surface areas of three-dimensional figures, specifically using formulas. So, we've been practicing surface area all week, and that is great. If you want to continue using nets, you are more than welcome to draw the net of a three-dimensional object every time you go to find its surface area. But we're going to dive more into what the formulas themselves look like. And the way we're going to split this up is we're really going to look at cylinders and prisms together because their formulas are very close. So cylinders we talked about yesterday, and we got pretty close to just writing out the formula. I even mentioned that you could see what the formula should look like. So we took this cylinder, we unrolled the label from around the soup can basically, and we drew out this net. And we said that in order to figure out this rectangle that forms our I think I forgot to use the term yesterday, so I'm going to use it now. This forms what's called the lateral area. And so I wanted to also include that in today's lesson so that you understand there's a little bit of a difference between two types of area we can find. The lateral area is the area of the lateral face. So we did talk about the lateral face as this rectangle here. And we said that in order to figure out the base of the rectangle, you take 2 pi r because that is the circumference of the circle, the base that it gets wrapped around. So by just finding the area of this rectangle, we are finding what's called the lateral area because the rectangle is in fact the lateral face of our cylinder. So we do that by taking 2 pi r times the height of the cylinder itself, 2 pi r h. Now, if we are finding the full surface area, we then have to add on the area of each base, which is pretty easy for a cylinder. That's just pi r squared. And since we have two of those, we can take pi r squared, multiply it by 2, and add that to our lateral area. So let's break this down for our formula here. Our formula takes what we find for the lateral area, which you will also see as the abbreviation LA, and we add to that 2 times the area of the base. Because we have two bases, so we can find the area of one, multiply it by 2, which is convenient more once we get to prisms because prisms could have a variety of bases, and so we generalize this a little bit to be the area of the base. So our lateral area here, specifically for our cylinders, so I'm going to go ahead and say that this is to find the surface area for a cylinder. Is we take our lateral area, which is 2 pi r h, and I'll explain the capital here in just a second. 2 pi r h plus 2 times the area of the base, which for a cylinder is pi r squared. So this is our specific formula to find, and I'm going to see if I can make this a little bit better here so we can read it. Our surface area of a cylinder is our lateral area, which is 2 pi r h plus 2 pi r squared. Now, why did I use a capital H? Because we talk about a lot of heights. Just generally when we're doing area, but also now that we've gotten into surface area and once we add on volume, we talk about a lot of heights. So typically what I'll do is I'll use a capital H when I'm talking about the height of a figure. So you could think of it as capital H because we're talking about a three-dimensional figure. It's like the big figure, so capital H. Okay. And then a lot of times too, you'll see that I abbreviate the area of the base as capital A, and then we use a little subscript here, area of the base. So just a couple of abbreviations, and you can see I did the same thing over here for surface area of a cylinder, just to notate what we're talking about because there's so many different types of figures. Okay, so let's generalize, or I guess let's talk about prism, and then we'll generalize this a bit to prisms as well. So if we take this prism and we draw its net, and I encourage you to pause the video here real quick and draw out the net and label all the dimensions. Okay, now if you pause the video and you drew this, the net should look something like one big rectangular face that actually is made up of all of these lateral faces. So all of my lateral faces here are rectangles because this is a triangular prism, right? The triangular prism means that my two congruent parallel bases are these triangles. Okay. The base is not the rectangle just because it's on the bottom. We are looking for those congruent and parallel faces. And those are what we call the bases of our prism. Okay, so this is a triangular prism. So my lateral faces are made up of all these rectangles. Well, I have 3 of those rectangles. So that looks like this. And then I would add in, and I notice here that I have these triangular bases that are also isosceles. So I can add in my isosceles triangular bases. Okay, so I mentioned I want you to label all the dimensions. That's very important. So if I go with these as being my congruent sides of my isosceles triangle, each of those would be 5 centimeters. And we don't have to put the units on every single one of these, but we can go ahead and just label 5. Now, if this side length is 5, it has to match up when I put this figure all back together with this piece that it's going to lay on top of. So this also has to be 5 in order for that to make sense. Same over here, 5 and 5, and up here, 5 and 5, 5 and 5. Now that only makes sense because the other missing side of this triangle was that base side of 6. So here's my, sides of my rectangle here, where the other missing side we need is the 12. And that should make sense that each of these have a height of 12. Okay, so there's my net. Now, in order to generalize to find the formula here, we're going to look at what I called the large rectangular lateral face, which just makes one big rectangle. So instead of finding, like we usually do with a net, we'll find the area of each of these individual rectangles. Let's just find the area of this entire rectangle. Well, how do I do that? Base times height. What is the base? 5 plus 6 plus 5, which also corresponds to the perimeter of my isosceles triangle here, because that is the piece that wraps around my triangular base, is this 5 plus 6 plus 5. So in order to find the base of my rectangle, I'm actually finding the perimeter of my triangular base right here. So 5 plus 6 plus 5, this whole thing would give me 16 times the height of my rectangles here, which is the height of my triangular prism. Okay, so what we've done here to find lateral area, LA, is we take the perimeter of the base and we multiply it by the height of the figure. So just like I did on the last slide, I used a capital P here to represent perimeter of the base. Just like how capital H here represents height of the figure. So we're talking about 3-dimensional objects. So we're using the capital letters to represent the perimeter of the base of the figure here. Okay, so that's the lateral area. The perimeter of the base, the triangular base, is 5 plus 6 plus 5 times the height of the figure, which would give me the lateral area, the area of this rectangle. Now to that, I have to add 2 times the area of the base. Well, we have to keep that pretty generalized here because this, remember, prisms could really have any base. This one, we're talking about a triangle. So we would find the area of our triangular base and we multiply it by 2. Okay, so this kind of brings us to our general formula here. And, again, any prism, but this also includes cylinders, we can think of the formula just like this. And this area of the base part, just as a warning, this could get tricky because we could be talking about a pentagon as a base. And remember chapter 10, pentagons, we have to use a little trigonometry to find an apothem if it's not given. So we're going to have to dig out of the archives our chapter 10 knowledge so that way we can find the area of the different bases we're asked to find. Now, the reason we can generalize what we've talked about in this video as this singular formula right here, cylinders included, is that this is talking about cylinders. We found the perimeter of our base. We multiplied by the height of the figure. We added on 2 times the area of the base. So I'm going to bring back that formula that we talked about with surface area of a cylinder here. And we can make this a little more specific. The perimeter of a base of a cylinder is the circumference of a circle. So 2 pi r times the height of the figure. And remember, that gave us that rectangular label that we pulled off of our can. So that's our lateral area, just like perimeter of the base times height of the figure is the lateral area of any prism. Plus 2 times the area of the base. Well, on a cylinder, my base is circular. So the area of that circle would be pi r squared. So what I hope that you are doing is that you are creating for yourself a reference sheet, okay? That reference sheet that I told you about in our first video, our very first video, is a sheet of paper divided into 3 columns. What we've done so far is we've talked through the nets of 4 different figures. Prisms, just generally, and I mean, you can pick. So I mean, for this second column, draw the net of these figures. For a prism, choose what kind of base you want it to have. It could be the triangular prism we just talked about in this lesson, or it could be pentagonal. It could be whatever you want it to be. Okay, the next figure, cylinder. The net of that's pretty specific because we have circular bases. Okay, now for each of these, not only have we discussed the nets, we've now discussed what the formulas look like. So in this third column, I encourage you to add in these formulas, the more general for all prisms, and then the more specific for when we get to cylinders here. Now, coming up in our next lesson, we will add on to this understanding pyramids and cones. I like doing those 2 together because in the same way prisms and cylinders have some commonalities, pyramids and cones also have commonalities in terms of the formulas. So if you haven't already, take the opportunity to draw a net of a pyramid and a net of a cone on your reference sheet, and we will add in the formulas for those tomorrow. Now, one thing you're going to do for your assignment today is you're going to do some practice with surface area here. These are some tricky figures that you're going to see. And so I encourage you to practice with whichever method you like the best. Try the formulas, see if you like it. If you prefer drawing a net, you are more than welcome to. But remember that you are going to do these problems, and I'm going to add on a couple more, and you will have to show your worked out solutions and attach those on Google Classroom for me. So good luck. Let me know if you have any issues with that. And I hope you're having a wonderful day.